In continuation with the previous topic of the differential amplifier, already we have seen what is the CMRR. CMRR is defined as the ratio of differential gain AD to common mode gain AC. We have seen the different type of the differential amplifiers. Now we will go for the important features of the differential amplifiers. It consists of high differential gain and low common mode gain, high common mode rejection ratio, high input impedance, low output impedance, high gain, and it is capable of rejecting the common mode signals such as noise. So consider example that for a differential amplifier, the two input signals V1 is 100 microvolt and V2 is minus 100 microvolt. Calculate the values of differential input signal and common mode input signal. If the values of differential and common mode gains are 2500 and 0.5 respectively, calculate output voltage and CMRR in dB. So this is the problem statement mentioned. We have to calculate the output voltage and common mode rejection ratio in decibel. So to go for the differential input, we know Vd is equal to V1 minus V2. So V1 is given as 100 microvolt and V2 is given as minus 100 microvolt. So 100 minus of minus 100, so it will be 200 microvolt. Then we can consider common mode input signal. So common mode input signal we can consider as Vc. So Vc is equal to V1 plus V2 by 2. So V1 is 100, V2 is minus 100. So we'll get 100 minus 100 is equal to 0 divided by 2. So your answer will be finally 0. So output voltage formula we have, output voltage is equal to differential gain into differential voltage plus common mode gain into common mode voltage. So it is AD into VD plus AC into VC. So differential gain is given as 2500 and the common mode gain into voltage is given as 200 microvolt. So finally your output will be 0.5 volt. So CMRR in dB we have to calculate, that is 20 log to the base 10 of differential gain to the common mode gain. So at 20 log to the base of 10 of 2500 divided by 0.5. So answer is 73.97. So finally we can round it up to 74 decibel. Then if you go for the ideal op-amp, so there are different characteristics for the ideal op-amps that we have to consider. An ideal op-amp would exhibit the following electrical characteristics. It is having infinite voltage gain AD, infinite input resistance Ri, so that almost any signal source can drive it and there is no loading of the input source. Zero output resistance R0 we can consider, so that the output can drive an infinite number of other devices. Zero output voltage when input voltage is 0. Infinite bandwidth, so that any frequency signal from 0 to infinite hertz can be amplified without attenuation. Then infinite common mode rejection ratio, so that output common mode noise voltage is 0 for the ideal operational amplifier. Infinite slew rate, so that the output voltage changes occur simultaneously with the input voltage changes. Then if you consider the basic symbol for the operational amplifier, so Opamp is basically a voltage amplifier with extremely high voltage gain, already we know that. For example, the popular 7.4 Opamp has typical gain of 10 raised to minus 6 dB, and the large voltage gain of Opamp is an important factor which distinguishes it from the remaining amplifiers. So the circuit symbol, if you observe, the circuit symbol is mentioned here. It consists of inverting input, that is negative, and non-inverting input, it is positive. We have the positive supply voltage plus VCC and negative supply voltage minus VCC, and the final output stage. The careful look at the circuit symbol of the Opamp, it reveals the different things. An Opamp has two input terminals, one output terminal and two supply voltage terminals. We can apply the input voltage which is to be amplified to any one of the two input pins connecting other pin to ground, or the input signal can be connected between the two input pins differentially. The input terminal marked with the negative sign is called as inverting terminal. If we connect the input signal to its terminal, then amplified output signal is 180 degree out of phase with the input signal. And the input terminal labeled with a positive sign is called as non-inverting terminal. And if we connect the input signal to this terminal, then the amplified output signal is in phase with the input signal. So that we can call as the non-inverting input terminal. So if you go for the basics of the op-amps, then we have to go for the important characteristics for this 741 along with those of the ideal op-amp. So this table indicates the basic characteristics, standard values and ideal values for the 741. So input resistance, if you consider, that is 2 mega ohm for 741 and it is infinite for the ideal value. Output resistance RO is 75 ohm and 0 for ideal. Voltage gain AV is equal to 2 into 10 raised to 5 and for ideal it is infinite. Bandwidth is 1 megahertz, ideal it is infinity. CMRR is 90 dB, ideal it is infinite. Slew rate is 0.5 volt per microsecond, that we can call as infinite also. Then input offset voltage is 2 millivolt, ideal it is 0. Power supply rejection ratio is 150 microvolt per volt, ideal it is 0. Input bias current IB is 50 nanoampere, ideally it is 0, and input offset current is 6 nanoampere and ideally we can call it as a 0. So basically here if you consider the PSRR is the power supply rejection ratio. The change in an op-amp input offset voltage due to variation in the supply voltage is called as power supply rejection ratio. It is also called as the supply voltage rejection ratio or power supply sensitivity. So mathematically we can call it as a PSRI is equal to delta VIOS by delta V. Then if you consider the slew rate, so slew rate is defined as the maximum rate of change of output voltage per unit time. So mathematically we can call slew rate is equal to dVO by dt. Then if you consider the bandwidth of the amplifier, it is a range of frequencies over which all the input signal frequencies are amplified almost equally. The bandwidth of an op-amp, it should be as large as possible. It should be capable of amplifying the signals right from 0 Hz. In other words, its frequency response should be extended right up to 0 frequency. Thus, the gain of an op-amp should be constant from 0 frequency to infinite Hertz. If you consider the CMRR, it is a ratio as defined as the ratio of differential gain to common mode gain. If you consider the input offset voltage, a small differential input voltage that is required to be applied to an op-amp in order to make its output 0 is called as input offset voltage. If you consider input offset voltage, then ideally for 0 input voltage, the op-amp output voltage should be 0. And if you consider the output resistance, it is defined as the resistance measured by looking into the output terminal of op-amp with the input sources short circuited. It is denoted by R0 and measured with respect to ground. Differential input resistance, if we consider, the differential input resistance is called as the input resistance. It is defined as the equivalent resistance measured at either the inverting or non-inverting terminal with the other terminal connected to ground. Then open loop voltage gain, if you consider, it is the differential gain of the op-amp in the open loop mode of configuration. Open loop mode is the mode of operation without any feedback. Then if you consider the output offset voltage, the voltage produced due to the input offset voltage is called as the output offset voltage. Thus, due to input offset, there is an output voltage produced even when the signal input is 0. A compensation network should be used in order to nullify this output voltage. Then if you consider the input offset current, the input offset current of an op-amp is defined as the algebraic difference between the current flowing into its inverting and non-inverting terminals. Mathematically, it can be considered as IB1 minus IB2. And already we have seen what is the meaning of the CMRR. It is a common mode rejection ratio. For op-amp, CMRR is defined as the ratio of differential gain to common mode gain. Ideally, CMRR it should be infinite, and practically its value lies up to the 90 dB. Input resistance is 2 mega ohm, and ideally it should be infinite. Output resistance is 75 ohm, ideally it should be 0. Bandwidth should be ideally infinite, and value should for the op-amp as 1 megahertz. Thank you.